So now we will derive the relation for couple per unit twist of a solid cylinder or a wire which is having a cylindrical structure. So what do we mean by torsion? Torsion, just like when you apply the force, there is longitudinal or the lateral change. When you apply the force in the angular direction, there is a twist produced in the structure. If we consider a wire where the downward at the free end, one end is fixed and other end is free, and in the free end, if in the angular direction, if the force is applied, then the twist is produced. So that twist leads to the torsion in the structure, or when the angular force is applied, the twist produced is known as the torsion in the particular structure. Now for here we will consider a cylindrical structure. If you take wire or if you take a cylindrical structure, you can view in the same way. If you draw any thin wire and its cross section, if you saw the cylindrical structure, it can be viewed made up of concentric cylindrical structure. So we have considered one such structure whose radius is r, the upper surface and the lower surface. The radius of the cylinder is r and the length of the cylinder is L. Now if we consider the two such cylindrical structure which are very close to each other, means shift of the radius is by the distance dr. So we can say the inside cylindrical structure has a radius r and the outward, which is just close to the previous one, is having radius of r plus dr. Now O dash is the here axis of the cylindrical structure. Now if we apply the force in the angular direction, as the upper is fixed, when you fix the upper end and the lower end, when you apply the force, what it will happen? The twist will be produced in the cylindrical structure. It is similar to like when we have to take out water from the cloth, we apply the angular force, so you can see the twist in the cloths what you have taken and water comes out. That is what is a twist. So similarly, if here we fix the above surface and on the free end or the lower end which is free, we apply a force in the angular direction. So what we can say, if first position, what will happen? Twisting means shifting of surface to surface in the angular direction. So if we consider that the original position when the force was not applied for a particular point on the surface of the bottom surface of the cylindrical structure is B, and when you apply the force, this point shifts to B dash. So if we consider a rigid point A, the original point at lower surface is B and the shift at that point after the application of the angular force is B dash. So the angle made by BB dash with point A is equal to phi, and the angle made by BB dash with the origin of the lower surface of the cylindrical structure is theta. So this theta measures the amount of twist produced in the structure. So we have considered a cylindrical structure and in this structure we can consider many number of concentric cylindrical structure. Now OO dash is the axis of the cylindrical structure. We have considered a cylindrical structure for which the upper and bottom surface radius is r. Radius of the ring which with the cylindrical structure is formed. And very close to other we consider another ring of radius d, r plus dr. This is of radius of the ring which is at the distance dr from the ring which has radius r. Now if we apply the force, angular force, on the free end of the structure, what will happen? Twist will be produced, that is what we call it as torsion. So this torsion, if we consider a point B on the bottom surface of the cylindrical structure, what it happens? It shifts to B dash. So if we consider a fixed point A on the above surface, then the angle BA B dash is equal to phi and angle BO B dash is equal to theta. This theta is the measure of the twist or the torsion produced in the cylindrical structure or the cylinder. So now we will consider the angle BA B dash, and if BB dash is the arc which is supported by the angle phi at the point A, then BB dash will be equal to L into phi, where L is the length of the cylindrical structure. L is the length of the cylindrical structure. And if we take the angle BOB dash, then BB dash will be equal to R into, comparing the two equations, as both the equation gives the arc length, what we get, L phi is equal to R theta, or phi will be equal to R into theta divided by L. We have the measure of the angle from which B shift to B dash. Now next we will find out the value of shearing stress and the shearing strain and calculate the rigidity modulus. So as per the definition, the shearing stress if we consider it is equal to T, it is equal to force per unit area. So it will be equal to force and area of a ring, it is equal to 2 circumference into the radius, means 2 pi r into dr. So it will be 2 pi r into the distance between the two cylindrical structure, that is dr. And phi change in the angle when the B shifts to B dash while the application of force. And we have learnt in the previous classes that the strain, the shearing strain, it is defined by the change in the angle when the position changes from one point to the other point. So this phi is nothing but the measure of the shearing strain. So what is your shearing strain? That is equal to phi r theta divided by L. So from the above two equation, what we can write, rigidity modulus of the cylindrical structure is shearing stress by shearing strain. Now we will substitute the value. We know rigidity modulus is defined by term eta, shearing stress force by 2 pi r into dr, and shearing strain is equal to r theta by L. So reciprocal value will be L divided by r into theta. So the force applied will be equal to eta into 2 pi r into dr into r into theta divided by L. F will be equal to what is in the denominator, that will be multiplied with the rigidity modulus. So eta into 2 pi r dr into r theta, and L will come to the denominator. So further we can write it as eta into 2 pi r square dr divided by L, and this theta will write it in the beginning itself. So force equation, it can be written as eta into theta 2 pi r square divided by L into dr. Now what we have to find? Couple per unit twist. And what we know, couple already I have defined, and couple is nothing but a torque, and which is equal to F into R, means force multiplied by the perpendicular distance from where the from the distance at which the force is applied. So therefore torque will be equal to F into R, and this torque is nothing but what it is? Moment of force, and this is equal to F into R. The perpendicular distance from where the force is applied, that is R. We will substitute the value of F. So what we get, the moment of force is equal to eta into theta 2 pi r square divided by L into dr into r. So what we get, moment of force is equal to eta into theta 2 pi r square into r is r cube divided by L into dr. The moment of force equation, what we have, rigidity modulus multiplied by the angle of twist 2 pi r cube L multiplied by dr. So now we have to find out the total moment of force. So the total moment of the force which can be represented by the total torque that you will get by integrating the left hand side from 0 to r, that is eta theta 2 pi r cube divided by L into dr. So constant term will take out of the equation. We get tau is equal to eta theta into 2 pi L and r cube, we have to integrate with respect to dr. So we will get eta theta 2 pi divided by L and integration of r cube will be r to the power 4 divided by 4 and we will cancel out this 2. So finally we get tau is equal to eta theta divided by L into pi r4 to the power divided by 2. You can write it as tau is equal to eta pi theta divided by L r to the power 4 by 2. This equation gives the total moment of force. Now what we have to find out, couple per unit twist. Which is equal to tau divided by theta. There, if we mention couple per unit twist by C, then that will be equal to tau divided by theta. So theta theta cancels out, eta pi by L r to the power 4 divided by 2. So equation 8 is the expression for the couple per unit twist of a cylindrical structure or simply of a cylinder. So now I am going to explain what is torsional pendulum. This is the last topic of the module 2. So when you hang a circular disc to a wire, and wire is fixed with a rigid support, and you apply the force tangentially, means in angular direction to that disc, what will happen when you apply the force, the wire will get twisted. So in the wire, what, due to elasticity, the restoring force it will act, which will try to retain the original shape and size, the original dimension, and hence what it happens, the disc rotates. Means due to the torsion produced in the wire, when the force is applied in the tangential or in the angular direction, then the disc executes a harmonic motion, and hence this kind of system we call it as torsional pendulum. So, a circular disc suspended using a thin wire that executes torsional oscillation, and this torsional oscillation is due to the twist produced in the wire or the torsion in the wire when the force is applied tangentially to the disc is known as torsional pendulum. Now, if we want to calculate the time period of this torsional pendulum, T will be equal to 2 pi square root of I divided by C, where I is the moment of inertia and C is the couple per unit twist, which is given by torque divided by the angle of twist. So, if we take the system, we will be able to calculate the moment of inertia of the disc and the rigidity modulus of the wire, and that is one of the objective of one of the experiment in the engineering physics lab,